Hello, welcome to Antcode, and today we'll be continuing with our top interview 150 series. We'll be doing the question remove element. So given an integer array in nums and an integer val, remove all the occurrences of val in nums in place. So we'll be given an array, let's say 1, 2, 2, and we'll be given an integer val, let's say it's 2. So every time that occurs, we're supposed to remove that in place. Let's read the rest of the question. Consider the number of elements in nums which are not equal to val bk to get accepted. You need to do the following things. Change nums such that the first k elements of nums contain the elements which are not equal to val. The remaining elements of nums are not as important, and the size of nums is also not important. And we're supposed to return k. It also has a custom judge. You don't really have to read it. It just means that it will check if everything is fine. I'll explain with a few examples. Let's say our input was nums equal to 3, 2, 2, 3. So the val given is equal to 3. Now we're supposed to return 2, 2, anything, anything. I'm saying anything because I don't think it's checking what's here. You don't really have to worry about what's here. Anytime 3 occurs, you'll just remove 3 and you're supposed to put 2 in that place. The next example is also similar. We are given nums equal to 0, 1, 2, 2, 3, 0, 4, 2. The val is equal to 2, so anytime 2 occurs, we'll remove 2 and shift everything towards the left, and we'll return the number of elements that are not equal to 2. So nums will be equal to this and we'll be outputting 5. Moving on to our brute force solution, let's say the nums given to us is 0, 1, 1, 2, 2, 3, 0, 4, 2. The val is given as 2, so we're supposed to remove 2 every single time it occurs in nums. Our solution will be that every time we see 2, we'll just move everything in the array one place left. So the array given to us is 0, 1, 2, 2, 3, 0, 4, 2. We set a pointer at the start equal to 0. So 0 is not equal to 2. We move the pointer one place ahead. 1 is not equal to 2. But now 2 is equal to 2. So we'll just move everything to the right of it one place left. The new array will look something like 0, 1, 2, 3, 0, 4, 2. At this step, remember that you don't have to move the pointer forward. You're supposed to check the place again because it can again have a 2. So our pointer is still here. We'll check it's still equal to 2. This array will now become 0, 1, 3, 0, 4, 2. Also, this 2 will still stay here and these will still stay as 2. We don't really care what's here, so I'm not writing it. Then moving on, our pointer will be here, then here, then here, and at the end it will be at the last 2, and we'll just remove this. And since there's nothing to the right, we'll just not move it. Just remember to keep the pointer here, so we return this size. I'll show you how to do it in pseudocode. Let's say we have the size as n. Then for I equal to 0 to end, which is the size, we'll say if nums I equal to val, then remove everything to the left. Everything left. This basically means for j equal to I, j is less than k minus 1, not till the end, j plus, what we'll do is nums j equal to nums j plus 1. At the end, we'll just return k. This should have a time complexity of O of n square and a space complexity of O of 1. This will get accepted, but at the end the interviewer is not looking for the solution and will ask you to optimize it even further. Moving on to our optimized solution, let's say we have this nums and this val. We'll set up two pointers I for scanning and k for writing. The idea is that we'll move I from start to end, and every time we'll be faced with two situations: if I equal to val or I is not equal to val. If I is equal to val, then we'll just move I one step forward. And if I is not equal to val, then we'll replace nums k with nums I. We'll move I and k both forward. So let's say we have 0, 1, 2, 2, 3. Just this. We set both k and I here. Now I, which is our scan pointer, checks if 0 is equal to 2. Let's say 2 is val here, and it's not. So it will replace nums k with nums I. So it will replace 0 with itself. Now we move forward. We do I plus plus, k plus plus. So I is now this, same for k. Again, it will just replace it with itself. Then we move on to 2. Now 2 is equal to 2. So we just move I one step ahead and we check again. So k is here, I is here. Now I is still equal to 2. So we move I one step ahead again. Now, since I is not equal, then we replace nums k with nums I. So this now becomes 3. And we move k one step forward and I also one step forward. Since I has reached the end, this will end the loop and we'll have 0, 1 and 3, which is the correct answer. The time complexity for this will be O of n and space complexity will be O of 1. The pseudocode for this is pretty simple. Set the right pointer k to 0. Set the scan pointer I in a for loop equal to 0 to end. And if nums I is not equal to val, then nums k equal to nums I and increment k. Remember, I will be automatically incremented in the for loop. This will be our pseudocode. The code for this is also very similar. You set k equal to 0. You run a for loop for I from 0 to the end. And if nums I is not equal to val, you increment k and you set nums k equal to nums I. So I is incremented here, k is incremented here, and the change happens in this row. At the end, you'll return k, which is the number of elements that are not equal, and the custom judge will check the first k elements of nums and it will check if k is correct or not. At the end, I've already told the time complexity. It will be O of n since you're going through the array once through the for loop, and the time space complexity for this will be O of 1 since we're doing it in place. That will be the end for this video. If you have any feedback, any comments, do let me know and I'll make sure to incorporate it the next time. Thanks for watching.